Okay, when we're dealing with limits and polynomials, there's two different types or two basic types. This is the first one where we've got the limit as x tends to 3 of x squared minus 4x plus 3 over x minus 3. And it looks as though this isn't going to work because the bottom's going to be 0. So we can't really figure it out when x equals 0. If that's the first thing we should do, try. What happens when x equals 3? Oh, it doesn't work. But sometimes it will. But in this case, it doesn't. So how do we do that? Well, we look at factorising the top. So we can factorise the top, and it just becomes x minus 3, x minus 1. We're looking for two numbers. Remember that times together give 3, add together give minus 4, over x minus 3. And again, this is still the limit as x tends to 3. And now what can happen is these two things cancel out. And what we're left with is the limit as x tends to 3 of x minus 1. So as x gets closer and closer to 3, we can solve this now, and the answer is just 2. So really, even though this looks like a quadratic, it would be a straight line, y equals x minus 1, so a straight line that looks like this, except the difference here, it doesn't exist at x equals 3. So there's a discontinuity. It's discontinuous, at x equals 3. But there is a limit as x equals 3, but it is not continuous. But the limit still occurs. Just remember, that's what Alan was talking about when he said that the limit doesn't care about the value at this point. From this side, it's getting closer and closer to 2, and from this side, it's getting closer and closer to 2. So the limit at x equals 3 is 2. The other thing that can happen is something like this, where we've got a polynomial on the top and a polynomial on the bottom, and we've got the limit as x tends to infinity. Now, this becomes a really big number, and this becomes a really big number, so it might just be a really big number over a really big number, which might be 1, but chances are it's probably not. So the way we do this is we look for the highest degree, or the degree of this polynomial is 2 and 2. So what we're going to do is take x squared out as a common factor. So what we get is limit as x tends to infinity of x squared, and what would be left in the brackets? 6 minus 2 over x plus 1 over x squared. And on the bottom, it would be x squared outside of 3 over x squared minus 5. And if you want, you can look at that and expand it back. When x squared times 6 gives us the 6x squared times this, one of the x squared x's cancel, and you just get left with 2x. And the x squareds here cancelling, you're left with 1. So we know it works. Now, obviously, this is just x squared over x squared. We don't care what that is, whether it's going to infinity or not. Those two things can cancel out. And what we're left with is the limit as x tends to infinity of 6 minus 2 over x plus 1 over x squared, all over 3 over x squared minus 5. Now, as x becomes really, really large, or as x tends to infinity, what happens to 2 over x? Well, that tends to 0. What happens to 1 over x squared? As x gets really, really large, that tends to 0. What happens to 3 over x squared as x becomes really, really large? That tends to 0. So this basically, as x gets larger and larger and larger, this basically becomes 6 minus 0 plus 0 over 0 minus 5. And that is just minus 6/5. So they're the two major types when we're dealing with polynomials that we might come across. Thanks. Stop it. They won't listen. Watch this part. Good. I can't remember how to stop it.